Hi everyone, welcome to my presentation about a new standardization in Java world named JCache. I will try to briefly tell you about JCache with its API and features. And at the end we will have a look at the code and make a quick demonstration with one of the vendor implementations with Hazelcast. Let me start with introducing myself. My name is Alparslan Avci, and I am a solutions architect at Hazelcast for nearly 2 years, actually. And I couldn't speak Russian, sorry for that. As you can imagine, I started my career as a developer, but my title has changed in years, and now I become a solutions architect, but a developer still lives inside me. I like to develop applications. And also, in addition to Hazelcast, I love open source projects, and I like to contribute them. Thus, I am an existing Apache Foundation PMC member at Project Gora, and trying to contribute as possible as I can. And other than that, I love to define problems and fight with them, and of course, love to solve them if I can. Yes, and before starting my presentation, I have some Hazelcast gifts with me. There are some stickers here. There are enough number of stickers, but only 5 t-shirts. If anyone wants these t-shirts, please scan this QR code and find the form, find the online form. Also, Dima has given me these beer tickets, so you will have a chance to 8 t-shirts and these 3 beer tickets. You can also follow the link above. I will wait a little. If everybody's okay, I can move on. In the end, again, I will show the QR code again. I think it's okay. Yes. Let's pass to the real content. Firstly, I want to start my talk with a classical definition sentence. What is cache? I will read directly from the definition because it's a long sentence. Cache is defined as a high-performance, low-latency data structure in which an application places a temporary copy of information that is likely to be used more than once. And since it is a long sentence, let us emphasize some of the words. Firstly, a cache should work in a high performance and low latency. It should because it will be meaningless otherwise. If your cache does not work fast enough, you can use persistent stores instead of using a cache. Because especially the infrastructures for persistent stores are really cheaper than cache infrastructures like RAMs, especially in high volumes. So a cache should work in high performance. And the second word is temporary copy. A cache should contain a temporary copy of the data. Why? Because if it contains the persistent copy, it does not become a cache. It is called persistent store instead. So we can say it should contain a temporary copy. And last one is a cache mostly contains data that is likely to be used more than once. If the data will used only once, then again using a persistent store is better, since there's already a cost of transfer from a persistent store to a cache. So you will not go through that cost. Here, it is meaningful than using a cache. Yeah, in summary, we can say that a cache is used to gain more performance and also to decrease the application latencies. Sorry for that. My mouse, yeah. Yes, okay. Now we know what is a cache, and now we can answer to this question, I think. When to use caching? There are two constraints, two main constraints. You can find more, of course. The first one is you should need data to be accessed more than once, as we said in the definition. And the second one is when fetching or producing the data, when accessing the data, it should be more costly to access it from a cache. So in here, of course, the cost means mostly a data access latency. Okay, in our application, we decided to use a cache. And here comes the question. How do we implement our cache? The first one, our first option, to build our own implementation. And believe me, this is not a good approach, and probably it will fail you on most use cases. In the beginning, at your application, if you want to build a cache, you start with a simple key value store. I'm assuming that you are all familiar with Java. You start with probably concurrent hash maps, and you will use it in your application. But then, after some time, you realize that you need some more features, like listeners. And you add it into your cache implementation. And again, after some time, you find that you need another feature and then another feature, like scalability, like persistent loading, and etc. And you add one by one to it, to your homemade, do-it-yourself cache. And in the end, your homemade cache becomes a fragile monster like this one. And of course, it changes according to the use cases, but I can say that building a cache is not simple as you think. It needs more expertise on most use cases. Okay, we given up on our homemade cache, so we decided to use proprietary caching APIs. Here comes you will face the issue of the reality of freedom. Because most of the vendors, most of the proprietary caching APIs have its own approaches to the caching, and of course the feature set differs a lot among them. So when you should choose one of them, you start with your application with one of them, and later on you will need some more features, or maybe you will need a feature that your chosen implementation does not have, but another one has. So you your migration process starts. But migration in a middleware is really a hard process to handle because the APIs are totally different. So you should probably rewrite your code from the beginning. Then what will we do? We will use JCache. It's simple. Actually, with JCache, you will get a standardized API, caching API, and it provides you the most used functionalities in caching use cases. And in the backend, there are a number of vendor implementations you can choose from one, and of course, it is child play to migrate from one vendor implementation to another one with using JCache. Since the API is standard, and they will use the same standardized API. Probably you will only change the library in the backend, and you will have your new implementation, new caching implementation. Okay, let's dig more about JCache, and let us have a look at the magic behind JCache. JCache is simply we can say that it is the standard caching API for Java, and it is built under Java Community Process Program, GCP, and the official name is called GSR 107. Its name actually, its code name, and the official name is Java Temporary Caching API, Java Caching Specification, or JCache is only a code name that we use actually. And don't forget that JCache is just an API, no more than that. It only gives you the specification. It gives you only the API. No implementation is defined in the specification. This implementation comes with the vendors or the vendor implementations. And we can say that it's similar to JDBC or GMS and the other Java APIs. So that is. Yeah. And who are the vendors? The first come JCache reference implementation. It is just an implementation for ensuring that the specification and the API works. It's not for production use. It's not intended for that. And the other ones, the full TCK compliant vendors are Hazelcast. We are proud of that. And Oracle Coherence, Terracotta JCache, Infinispan, and more. There are more than these ones. These are the most used implementers. Yes, in the JCache specification, no topologies are defined or restricted. What does it mean? This means that you can implement JCache in a local way without replication, or you can also implement JCache within a distributed system and also with or without replication. So it supports both of them. And let's come to the runtime structure of JCache API. In the right top corner, you will see the application. This is the application that we intend to use caching. And it needs a cache interface in the right-hand side. This cache API actually provides some operations, some methods to do operations on your cache, on your literal cache. You can put, invoke some operations by using this cache interface. And also, we have one higher level, you will get the cache manager. A cache is created and managed by a cache manager. This cache manager actually is defined in a scope, and it allows you to configure the caches and also creating and destroying them with a uniquely named cache, with a unique name. And also you can iterate over all the caches in the scope, and more than that, you can also define the class loader that is wanted to be used, blah, blah, like that. And at one higher level, you will see the caching provider. Actually, this is the SPI implementation of the vendors, and it provides you to create and manage cache managers. And at the top, we have a caching bootstrap class. This is a service loader class, actually, not interface. And this class provides you to get the available vendor implementation. It gives you it loads and tracks the caching provider, and its use is not mandatory. Actually, the vendor implementation can directly initiate, can provide the methods for directly initiating a caching provider. You don't have to use caching class. And from top down, let us summarize the runtime structure. Application first get the caching bootstrap class, and it gets the caching provider that is available. And then by using this caching provider, we build a cache manager, a scope for the caches, and then by using this cache manager, we create caches that we have to that we need to access to the caches. Yes, let us stop the talk and let us have a look at the code. That's the better part. I will go over line by line. At the first line, you can see that caching class, by using caching class, we get the default available caching provider. This line won't work if you don't put a vendor implementation in your class path. And if there is one, it will automatically get the related caching provider. And the second line comes with, by using this caching provider, we get the default cache manager. You can, of course, there are more than this method that you can define the scope and other things and URI either ones. And now we prepare our configuration for the cache. Firstly, it's as you can see, there are generics and other things. And we create the cache by using cache manager. And in the end, we have now our cache instance in our hands. And we can use put method to put something into it and get method to get something. And there are other methods to use to use in your cache actually. Yes. Okay. JCache of course does not have only get and put methods. It provides you more features. One of them is entry processor. I like entry processors because they are really great, especially in distributed systems. They provide you to. First, I want to tell that they are like field harvesters. The product is on the field, so you send your harvesters to the field, and they do perform on the field. Like that, entry processors used to send your atomic function to the data to the place where data is stored. So that will help you, especially on distributed systems, because it eliminates the round trips on networks. And also, its entry processor enable you to build a lock-free API, lock-free application, because you don't need to use locks on your entries by using entry processors. Another feature is listeners. Probably you all know what a listener is. They are classes and interfaces for handling events produced by a cache, actually. And you can register a cache listener, for example, a cache entry created listener, to get the related updates and do some operations according to these updates. And of course, they follow the observer pattern, which means that if an exception is thrown inside the listener code, it won't fail the application itself. Another feature is loaders and writers. These interfaces allow you to integrate your cache with persistent backend store, and you will you will probably need them to load and update the data from your persistent store to your cache. There are two interfaces. First one is cache loader. It is used to load the data, and also the other one is cache writer. It provides you the interface to store your data in the persistent store. You can use any backend resource, any external backend resource, and these interfaces are not implemented by vendors. They are for end users. So as an end user, you should implement cache loader and cache writer according to your backend store. The API will call automatically according to your configuration. And yes, we are greedy developers. So we need more features. They are not enough for us. And JCache provides some more. First one is annotations. Some annotations comes with the specification, like cache result and cache put. These annotations help you to easily use your cache, access your cache. especially in a container like Spring. And also there comes another feature that's called expire policy. You can set the expiration time or date to your entries, so they will be invalidated after that time. Also, you can find some statistics in the API. These statistics can also contain hit count, miss count, and etc. Yes, and of course, like all software applications, JCache is not perfect. There are still unavailable features. First one is async operations. JCache specification does not provide you any async operations in the API. We expect it to be added in future because it is really needed. And also an eviction other than the expire policy is not provided in the specification. Again, eviction is mostly used in caches. And also you cannot query your cache by using the API. There are only direct access methods. Of course, these features are provided in the specific implementations of the vendors. But when you get the specific implementation, of course, you are out of the standard. So the trade-off comes out over there. And the future. In near future, actually, we expect Java 8 features will be added to the specification, like lambdas and streams. And also Servlet 4.0 integration and session caching will be also available. And also there will be a Java EE alignment we expect, but that is not determined yet. And in a more distant future, Java 10 language features can be maybe also added to the JCache. And yes, this is a summary, actually. I will do my demonstration like right now. You can again find the project hosting from the link at the top. And also you can access the source code on this GitHub repository. And you can ask your detailed questions on the Google Groups. And this QR code is again for the lottery. This is an empty project, as you can see. There's nothing in it. I will firstly start for adding some dependencies onto it. I will add firstly the dependency of JCache itself. This library just contains the API, and now I should add add a vendor implementation, which will be Hazelcast for our use case. Yeah, let us also change the latest version. Yes, this one. That's okay. Now we have all the needed libraries in our hand. Yes, let's add our first class. Let's make its name JCache. JCache demo. Yeah. Let's add our main method. Yeah, I will quickly write the code sample in this presentation. I will get my caching bootstrap class first, and get caching provider, the default caching provider, and this line will give me the default caching provider, and then by using this provider I will get my cache manager, and yes, now I can create cache first, but of course, when I create the cache, you can see the parameters needed. First one is the cache name, and second one is a configuration. So let us create our configuration first. it will be a complete configuration. I will give some generics. Let's make it simple. This will be an integer string one. Yes. Sorry. Configuration. Let's make it simple. New mutable configuration, and let's specify the types here. First one is integer, that's class, and the second one will be string, that's class. Okay. Now we have the configuration. We can just give a name to our cache, JCache demo. Let's make it, and also let's give our configuration. And this line will create our cache. And now we have the cache instance. We can add, we can put and get some information into it. As you can see, there are lots of methods here. Let's put something first. Let's make it simple one. This one puts an entry to the cache with the key 1 and value MISC. And if we want to get this value again by using the key 1, and let's make it written on the screen, on the console. And of course, add some more beautiful code here. Value is, yes, it's ready. Now I can start this one, if I can, of course, because my mouse tracking is not available. Okay, here is this one. Yes. As you can see, it starts with a Hazelcast instance because the caching API get the provider in the class path, and you can see that Hazelcast has just started with only one member, and we print out the value as MISC. That's easy. Let's add some other features. For example, let's add a cache that's invoke. Yes, let's add an entry processor. As you can see, it takes a key, an entry processor, and some arguments if you want to send it to the processor. Let's make it 1 again, and let's sorry. Integer. This is the key type. This is the value type. This is the return type. Let's make it also string. Okay. Yeah. Now we have the process method. Let's return null, and we can use the entry parameter. And as you can see, you can get the key, you can get the value, and also you can change the value by using this entry. Let's use entry set value, and let's modify the value a bit by getting the value and adding some more. For example, let's add processed. Yeah. And the semicolon here. Yes, now we should see MISC.processed. Again, Hazelcast instance has been starting. And yeah, as you can see, value is now MISC processed. I can say that it's not so hard. The API is not so complicated, I think. And you have not seen much configuration here. You can do the configuration by using XML files, and also you can do the programmatic configuration. It's not as easy as maps, of course, concurrent hash map and just Java util map interface, but it gives you the ability to use a default API to use to access a cache with default with different implementations. Yes. So that's it. Is there any question? Thanks. Thank you very much.
Between two applications. Once again.
Sorry again, please.
How to share this cache in your example between two applications?
Actually, it differs according to your vendor implementation. For Hazelcast, you can just start another instance. For example, if I start this one first, let us run this. It starts an instance here. For Hazelcast, it's easy because Hazelcast communicates in the backend by using multicast. You can directly discover another instance. Let's change this one so we can see the update. For example, processed by other one. If I start also this one, and let's not put this cache. So now, as you can see, another one is starting up, and it's trying to find the other member here. And yeah, two-membered cluster has been created, and you can see that the value means processed first by the other one, and secondly by the second instance. It changed according to your vendor implementation, as I said. For example, for coherence, it changes more, and also you can give the Hazelcast has also provides you lots of more configuration parameters, so you can also configure to build up a cluster with using TCP/IP, and also you can build up a cluster on cloud environments. So it changes. It doesn't since the JCache API does not say anything about topologies. You will find nothing about these things in the caching API. Welcome. Yes.
On last project, we use Hazelcast and have problem with performance. Mostly time we spend in coder, decoder, and what we can for increased performance.
Actually, that's a company question. I can say that you can get professional support. No, not that one. Actually, let me give you the correct answer. Hazelcast is a really big project. There are lots of features in it. It's not like, for example, regular Redis. I'm not talking about cluster Redis. It's not like regular Redis or Memcache. Since there are lots of features in it, you should optimize the configuration parameters according to your use case. So I can say that if, for example, if you use default Hazelcast configuration with large objects, you can suffer from something. And for example, I can say if you use Hazelcast with default serialization method, with default Java serializable, then you will again suffer from performance. But if you have a starter project, you can use default configuration. But there are lots of configuration properties and parameters, and you can see them in the documentation page. And also, you can ask to Google Groups or Stack Overflow. You can raise a question on Stack Overflow. Somebody will answer that one. Because it changes according to your use case, as I said.
Main problem what we find it's Hazelcast cache coded well and always return new clone, new object. For example, we try customize and set object type for caching, not byte encoding, no, not binary type object, but in this case, Hazelcast always invoke clone for cached value, and if we try get value on clone on cached value and return always new value.
Actually, since Hazelcast is a distributed system, it should serialize the objects, and probably you should also define something on your serialization classes to do this correct cloning operation, because it gives the object itself is stored binary on the backend if you didn't configure it as object. Again, if you have already stored it as object, while you are getting it, we should again serialize and deserialize it to available to you, because it goes on the wire. We couldn't do that, so you should again prepare your serialization methodology according to your clone method.
Thank you.
Just a follow-up question to the first one. So just to clarify, the intended deployment way for JCache is you have this API plus implementation in the class plus vendor-specific configs, right?
I couldn't get your second one. First one.
That's the API. Then the implementation in the class path, right? As a dependency, and then what I guess we haven't seen here is a vendor-specific configuration where you put all those evictions and vendor-specific features for the specific regions or of the map or whatever.
Yeah,
right?
I got it. Actually, the API has. First, let me show you the POM XML. Let me go over it again. The first dependency here is the API itself. So it does not. It does only contain the API, the specification. And the second one, the Hazelcast one, is the Hazelcast library itself, and it contains the implementation for JCache inside, and the configuration comes with actually, as you can see here, you can configure your cache and also cache managers with a programmatic approach, and also you can use an XML file to use a declarative approach. These are also defined in the specification, these configurations parameters. So you configure these, you configure your cache by using these configuration files, configuration classes, and then you can change your vendor implementation, and you can still use these configuration parameters with the new implementation.
Yeah, I got it. Say I want to get the most of the Hazelcast. Can I configure the JCache-dimmer in the Hazelcast XML file to specify all the expirations, all those properties?
Yes, but it comes with some problems, because then now you will go out of the API. We provide as Hazelcast, we provide you another instance. This name is iCache. Actually, this iCache is the backend data structure for JCache, and you can get your iCache instance, and you can configure it with these parameters, and you can add more properties like eviction, like async operations. But of course, this time you are out of the boundaries of the specification. So when you change your vendor implementation, for example, if you migrate to Terracotta or Coherence, then you may need to rewrite your code.
Okay, makes sense. Thank you. And one a general question on JCache. So this standard is, I think it's fairly late into the existence, because I think major players have their products out, including Hazelcast, I guess, for more than a decade. So do you see levels of adoptions on the end users, not across the vendors, but across the developers?
This is a good question, and we are suffering a lot from this one. Actually, specification implementation has been started more than 10 years ago, I think. It has been started 2003 or something. It is one of the longest GSRs. And as you said, there are lots of providers that their own cache implementations, like Hazelcast. Most of them prefer to wrap their implementations with this API. Hazelcast didn't do that. Hazelcast, our engineers have used their experience and tried to write a new implementation from scratch. But we will see in the future. I couldn't say anything for now because it is so new. We don't, as a confession, we don't have so much users right now, JCache users. We have, of course, most of our users are still using Hazelcast map, but I don't know, it is public, but Apple is using it.
So many people use Redis,
Mm-hmm.
and can you compare them in terms of performance and features?
Hazelcast with Redis?
I mean, many people uses.
Do you want me to compare Hazelcast versus Redis? Or
Yeah, is it comparable?
Because you couldn't compare JCache to Redis because JCache is only an API. But if you compare Hazelcast to Redis, I can say that if you just need a cache and a backup, if you don't need any scalability, I offer you to use. I suggest you to use Redis because it's simple. It does not have. You don't need so much. What can I say? So much configuration parameters or something like that. But if you need scalability on your application, then you should use Hazelcast because Hazelcast corresponds to clustered Redis. Regular Redis and Hazelcast are not the same product.
Yes, I'm mostly talking about clustered Redis.
Yeah, but if you are talking about clustered Redis, I can say that we have just published a new benchmark, and Hazelcast is faster than clustered Redis, and it's also easier to set up. And also, you can use as a dependency in your application, for example, as microservices. You can add as a dependency the Hazelcast library, and you can raise a new instance when you are starting your microservice instance. It is more easier, and you get more performance.
Okay, thank you.
You're welcome. You can check out the hazelcast.com page to get the benchmarks over there. Yeah.
Do you have any plans to implement right behind cache in Hazelcast, or how can it be done?
Actually, you can use cache loaders. For JCache, you can use cache loaders to implement the right behind cache because it allows you to both methodologies, cache right through and right behind. You can configure your cache loader as to be updated. The person store will be updated as you updated the cache, and of course it will be synchronous. And you can also asynchronously you can also configure cache writer as to update your backend store in an asynchronous way. By using cache right behind methodology. It is available, just you should configure it correctly.
Could you please clarify, am I correct that JCache API is just talking about something, not about how it running on a single node or on a distributed machine? Am I correct here? And the real question is, do you aware of some plans to include, for example, some API or configuration into JCache that will, for example, allow me to set up some kind of data locality? For example, I have several instances of my app servers, and I want to, from each app server, to go to the closest, for example, part of my cache. Is it possible on, for example, Hazelcast, and will it be possible in JCache in some foreseeable future?
In JCache, the topologies are not defined, and the vendors are free to implement both of them. You can build a cache implementation on your that will run on your local machine, and also you can implement a cache implementation in a distributed way. That's both possible. Hazelcast does this in a distributed way. And your second question was for transactions.
Is it possible to set up data locality somehow? So, for example, I want to go from my from one app server to go to particular machine with part of my cache.
Got it. Actually, in Hazelcast, there is a way to do that, but we don't suggest our users to use it, because then you should do it you should really manage your cache very well. The best way is to make it done by Hazelcast itself. Hazelcast normally distributes in a normal distribution, we can say. The data is distributed among all the members, and you can define the partition when you are putting the entry, but it's not a preferred way, actually. But it's not available for JCache implementation, I think. It is just available for Hazelcast map implementation. But we don't, in distributed computing, we don't prefer to do that. It is really painful, I can say, because you will get some problems in future. You should do specific configuration for each machine, and you should also know all developers should know which data will go to which place. So it's hard to play, I can say. Any more questions? Okay, thank you very much. You can get the stickers from here. I hope it's a good presentation for you, and you get well informed. Thank you very much.